Hello students, myself is Parminder Singh from Prab Kripa classes. Our today's topic is DBMS Module 3, DBMS Advantages and Disadvantages, Locking and Isolation Levels, and the benefits of using a DBMS over traditional file-based system. After going through this course, the students will understand that there are many benefits of DBMS such as data independence, data integration, data security, and much more. The students will understand that data independence means that if we make any change to the storage format or make any changes in the tables where the data is stored, all such type of changes do not require any changes to be made to the programs which interact with the database. The students will understand that data redundancy means duplication of data. The students will also understand the meaning of data integrity, which means that the data provided by the DBMS is accurate, reliable, and consistent. The students will also learn about the meaning of data integration, that DBMS ensures the data from different sources is integrated to provide a unified view of the data so that the organization can take timely decision to improve the performance of the organization. Data consistency means that the data is the same for all the users who are viewing the same data at the given relevant time. The students will also understand that the primary techniques used by the DBMS to enable concurrent data access are locking, transaction isolation levels, and transaction management. Then the students will understand that the term locking in the DBMS means that if the users are accessing a resource for reading or writing, the DBMS system can place a lock on that resource so that the other users cannot manipulate or change the data. The students will learn about read data, read lock and write lock in detail. The students will also understand the meaning of isolation levels. The students will learn that there are 4 isolation levels and they will have some more details about the same. The students will also learn that the DBMS is now preferred over traditional file-based system because of the various benefits the DBMS has. The students will also understand that the DBMS also has many disadvantages in the form of huge investments, or there may be some data redundancy issue, or higher levels of skills may be required to operate the DBMS system, or careful planning and expertise is required if we want to make use of DBMS. The students will learn a lot about the limitations of DBMS. Now the topic before us is advantages of DBMS. Now, database management system offers several benefits that contribute to effective and efficient data management. Here, There are many benefits of DBMS which are given here. First is data organization, data analysis, data independence, data backup and recovery, reduces data redundancy, and so on. We will learn about each of these benefits one by one. First is data organization. Database management system provides a structured and organized way to store and manage data. DBMS uses tables, rows, and columns to represent data in a clear and logical manner. Here, the reference has been given to a relational database management system where the data is stored in the form of tables which has rows and columns. There are other forms of databases also, such as NoSQL database, object-oriented database, time series database, which help in storing and managing different types of data. Next benefit is data analysis. DBMS provides various tools and features which allow users to perform analysis of the data stored in the database so that they may gain valuable insights and take informed decisions. That is, DBMS helps in the analysis of the data which is stored in the database, and on the basis of the data analysis, any organization can take decisions which are in the interest of the organization. Next is data independence. It is one of the important benefits of DBMS. Now the question arises, what is the meaning of data independence? Data independence means that if we move data to different disks means hard disk or SSD, or change the storage format, modify the table structure, add or remove columns, or change relationship between tables, all these types of changes do not require changes to be made to the application programs or queries that interact with the data. We understand the same in some length. Suppose we are having data in a hard disk drive. Due to increase in the volume of the data, we add more hard disk drive in our computer system. Next is change in storage format. Suppose we may be using a relational database management system to store the data in the form of tables, but with the passage of time, we are also having on our website the data which may be unstructured or semi-structured. So we may be moving from a relational database to NoSQL database. Next is modify table structure. It may be possible that we are having data stored in our database in the form of tables. Suppose there is a customer table and we want to increase the loyalty of the customers, and to include that in our marketing strategy, in the customers table we add one more column which reads as customer loyalty points. So this is the modification of table structure. Next is add or remove columns. Suppose we are having a customer table in which we want to add a column date of birth. With the passage of time, it may be also necessary that some columns in the table or the database may become unnecessary, such as we think that the address is physical address or correspondence address is not required, email address will be sufficient. We remove the residential or office address, we remove that column. So this is the example of removal of column. Next is change of relationship between tables. Sometimes we have to change the relationship between the different tables such as customer table, order table and other tables. So when we are making all these changes, that is, there is change in the different disks where the data is stored, change in the disks, change in the storage format where the data is stored, how it is stored. When all these changes are made, it does not require that we have to make any change in the application program which has to interact with the data. Our DBMS system is a very clever system, and it will see that the application program is able to fetch the data from the database. Next is data backup and recovery. Sometimes it happens that there may be a accidental deletion of data. There may be human error. Sometimes there is a software bug or hardware failure. All these types of situations may result in the loss of very important data. So to take care of all these scenarios which are detrimental to the interest of the organization, DBMS provides the facility of data backup and recovery. DBMS automatically takes care of data backup and recovery. The users need not backup data periodically because this is taken care of by the DBMS. Regular backup protect the data against system failures, data corruption, accidental deletions, and ensure that the database can be restored to a previous state, minimizing the risk of data loss. It means that if the regular backup is taken up by the DBMS, it helps the organization in its smooth functioning because the data can be restored to a previous state. Now the question arises कि where the data backup is stored. DBMS where stores the data? DBMS stores data in a place which is other than the main database server. That is, if the database server is located at suppose this location, now the backup database server will be located at some other location, or the backup will be stored in the some cloud server, some other server which is located at some distant location which is physically away from the main database server, or the data backup may be stored in the cloud server. Now next benefit of DBMS is reduces data redundancy. Redundancy means duplication of data. In DBMS, data redundancy can be controlled or reduced but is not removed completely. It helps in the controlling or reducing of data duplication. Data redundancy means duplication of data in multiple places within a database. Now the question arises, how DBMS controls or reduces data duplication? It makes the use of normalization techniques and data integrity constraints. Next benefit of DBMS is data integrity. Data integrity means accuracy, reliability and correctness of the data stored in the database. DBMS ensures data integrity by enforcing rules and constraints on the data stored in the database. These constraints include unique constraints, primary key constraints, foreign key constraints, referential integrity, etc. DBMS prevents the insertion of inconsistent or invalid data. Now we will have some more view of the unique constraints, these types of constraints. What is the meaning of unique constraints? Unique constraints, the example is social security number in the case of employees, so that there is no identification duplication or identification problem in identifying a particular employee. The example of primary key constraint is maybe the customer ID in the case of employees table, employees records. The example of foreign key constraint may be that there may be a order table and a customers table, and in the order table there may be a reference to a customer ID. Customer ID is the foreign key in the order table and it refers to a another table, that is the in the order table. When there is mention of a customer ID, it makes reference to a customer which is existing in the database. Now the next is referential integrity. Referential integrity means whatever we are referring to in a data, it must exist in the database. For example, we are having a large number of employees in our organization, and we are having salary record where the employee ID is used, and then there may be some other benefits which we are giving to the employees. There is also mention of employee ID. So when we are making use of employee ID, thus the record of that employee must exist in full details somewhere in the database. That is the database, that is the data which we are referring must exist in the database. Then there are some other constraints also which you can understand, such as which may be the default constraint. For example, a new employee joins your organization. If there is no DBMS system, you can, and the person is known to you, you may say that today is say going on August, and you can make its entry in July that the employee has joined in previous month. But DBMS does not allow the same. It may have default constraints, that is when the employee joins the organization, it will be automatically taken in to have joined on the current date. That is, if today is 1st September, the computer will automatically, DBMS will ensure that the date of joining of the employee is automatically taken as 1st September of the relevant year. Now the next example of this data integrity is, suppose a new customer account has been added to the bank database. The DBMS enforces data integrity by enforcing a unique constraint on the customer account number. It means that suppose you are having the accounts, these are the customer account numbers, next is 1 2 3 4 5, next is 1 2 3 4 6. If another customer comes and you also allot him 1 2 3 6 in some other table, then the DBMS system will enforce data integrity and it will not allow that the another customer to have this account number. It will not allow. DBMS system prevents creation of two accounts with the same account number, ensuring that each customer has a unique identification, that is the customer account number is different for different customers. Unique constraint ensures that all values in the specified columns are unique. That is, suppose there is a table, here it is serial number, it is the name of the customer, Here it is the account number. Customer name may be same. Suppose it is Sham. Name of the other customer may also be Sham. But the account number will be different. This here the system allows that the same number may exist. But here the unique constraint does not allow that the same account number be allotted to the same, though the name is same, but this constraint does not allow that the same account number should be allotted to another person which is thou having the same name. Next is data security. In these days, the companies are investing a lot of money and efforts to ensure that the data is secure, because the cyber criminals are very active who want to befool people by way of ransom attacks or by way of having unauthorized access to the data. Database management system ensures or incorporates security measures like user authentication. It means that only authorized users are allowed to access the database and their identity is authenticated using a username and password. That is, to access any database system, DBMS provides for username and password. When you enter the username and your password, only then you can have access to the database. DBMS also allows role-based access and time-based access. What is the meaning? Role-based access, we understand the same first. Suppose you are working as a branch manager in a particular organization. So you will have the access to all type of data which may be pertaining to your branch, such as if you are working in a bank, you will have access to how many customers are there in your branch office, how many types of accounts a particular customer has, how much deposit a particular customer has taken, a customer has deposited, how much loan a particular customer has taken, or what are those persons who are defaulting in the payment of loans. So you will have the access only to the data which is pertaining to your branch. You cannot have the access to one level higher. Suppose the RM, regional manager, will have more access to the data because he will be having many branches under its control. He can overview the data pertaining to a large number of branches which are under his control, his or her control. So this is the meaning of role-based access. You have the permission to access the data which is stored in the database only on the basis of the role assigned to you by the higher organization. Next point is time-based access. Suppose you are working in an organization and your working time is, say, from 4 in the afternoon to say 10 in the evening, 10 at night. That is, your duration is only of 8 hours. So you will have the access only during this point, and after this point, after this 8 hours, you will not have access to the database. Another employee may be having after that shift after you, that employee will have the access to access the database during the particular time period which has been, for which he has been asked to work, and the DBMS will allow him to access the database only during that period. He will not be able to access the database other than that time. So this is the meaning of role-based access and time-based access. Now the next benefit of DBMS is scalability. What is the meaning of scalability? Scalability means if the data of the organization which a particular organization or the DBMS has to handle increases, the number of resources or number of computer systems can be increased. It means scalability. Scalability can be up or down. If the database or the number of the data which is to be handled by the DBMS increases, so naturally you will have to increase the computer systems or other resources to handle the data. If the data which is to be handled, the working of your organization has decreased drastically, so naturally you will not require many servers, many computers or many machines to handle the data. So all these types of resources will have to be also reduced. So DBMS helps in that. If the data increases, we can increase the resources to make up the performance accurately. And if our data or the requirement of the large data decreases, that is, we are no longer required to manage more data, we may reduce the resources. Now we read what is written. DBMS can handle large amounts of data and can scale up or down to accommodate changing data requirements. Scaling down is less common. Scaling down means to decrease the resources. Suppose we have one computer and we are having in it a device or things like CPU, RAM, hard disk. So it is not possible that if the working or data which is to be stored in our computer system has decreased, we can change the RAM or change the CPU or change the hard disk. It is not possible or not so easy. It is less common. However, the vertical scaling and horizontal scaling is common. Vertical scaling means that if the data requirement, volume of data increases, we can increase the capacity of the CPU, RAM, hard disk. Horizontal scaling means, suppose we are having 10 computers or 2 servers to handle the data, and our workload has increased, our business is flourishing many times, increasing, we are our products are selling like a hot cake. So in that case, we can also increase the number of servers or the number of computers to handle the volume of data. This is horizontal scaling. So DBMS provides the facility of scalability, that is scaling up or scaling down. Next is data integration. It is also one of the important benefits of DBMS. Data integration in a DBMS refers to the process of consolidating data from multiple sources and formats and providing a single coherent view. We will also have an example of the same. Data integration involves techniques like data warehousing, data transformation, ETL processes. Data integration plays a crucial role in decision making. Suppose we are having multiple offices in multiple cities, and there are many products which are sold in these branches, but each branch is having its own computer system. It is not connected to any other branch. And if we are sitting at head office and we want to see that what is the position of the sale of the particular branch, what are the various products which are selling in good numbers in the particular branch, we are not in a position to have access to the data because the data is not integrated with one another. We will have to send them email or we will have to ring them to inquire about the same. What is the position of the sale? What type of products you want? DBMS here helps. It integrates the data. How? We can have a database, centralized database server, where when a particular product is sold in any branch, the same data will be saved in the centralized database server, and while sitting at the head office or where we are in a position to make any decision on the part of the organization, we can see that what type of products are being sold in the particular branch, whether inventory is proper in the particular branch, or in the case of festival season, which type of products should be present in the particular branch. So we can have a coherent view or unified view of the data, whether sales are increasing in all the, in which branches the sale is increasing and where the sale is decreasing. If the sale is decreasing, we can decide to find out the reasons why this is so. So let us read what is written. The company uses DBMS to integrate sales data from all its physical stores and the online platform into a centralized database. With integrated data, the retail company can analyze customer behavior, buying patterns more effectively, optimize inventory management, that is where the products are in short in inventory, in which branch, we can then immediately send the more products to that particular branch, track the performance of marketing campaigns, and respond quickly to market trends. That is, if the particular products are not selling and the market trend has changed, so we will not no longer purchase those products, and we will purchase those products which are in demand as per the demands of the customer. Data consistency, it is also one of the benefits of DBMS. What is the meaning of data consistency? It means the uniformity of data across the entire database system. What is the meaning of that? Suppose we go to the Amazon website. There are 5 persons sitting near you. They are also visiting the Amazon website. Suppose all of us, 5 or 6 persons which we are sitting, all are viewing the Amazon site on their own respective mobile phone or computer or tablets or whatever it may be. They are looking for a particular brand or particular type of product, say shirt, and each is looking for a particular type of shirt. Then the Amazon site will show you the same product or in same quantity to all the viewers. Suppose there the product is showing that it is of $100, so all the persons will see that this is of $100. That is, it is consistent. If it is the case of inventory, there all the employees working in the organization will see that the products in the inventory are 100. It is not that one will see that it is 99, other will see that 100. No, DBMS ensures that the data is consistent for all the users who are viewing the data in the database at any given time. The importance of data consistency is more relevant if the data is to be used for regulatory compliance. When the data is consistent, users spend less time cross-checking information, and they can focus more on analyzing the data. For example, in the case of online banking, there is data consistency. Suppose you want to check your account balance, you go to the ATM and use your card and do the necessary formalities such as entering PIN or other, and you find that your balance is $100. You immediately open your computer and through online banking, and you find that on the mobile app also this your balance is $100. You go into the bank branch and ask the person on this bank employee that what is my account balance. He will also tell that your account balance is $100. So whether you go to the ATM, do online search in your account by visiting your online account, or you go to the branch, the account balance will be the same provided no transaction has been made online. Suppose there is a dividend payment in the meantime the dividend has been credited to your account, it is separate issue. Otherwise the data will remain the same. Whether you check your balance through a mobile app or website or ATM, you expect to see the same information. This consistency in data eliminates confusion and it ensures that you can trust the accuracy of your financial information. Now we will take another example of data consistency in DBMS. In e-commerce platforms, data consistency is very essential in managing inventory levels. Suppose a customer purchases a product. DBMS ensures that the inventory of that product is immediately updated so that the availability of the product shown on the site is the same which is in actual. Suppose there are 100 products which are available. So one product has been suppose purchased by you. DBMS will ensure that the actual inventory which is shown on the site is reduced to 99 immediately. When the order is executed, immediately the inventory is also updated. Suppose there is only one product, you have purchased one, the balance is 0. And if the DBMS system does not ensure that the inventory is 0, there may be some order placed by many other customers, it will result into customer dissatisfaction, because then the problem of making the refund or tackling the customers grievances will arise. So this feature of DBMS of data consistency prevents overselling, where the same product is sold to multiple customers, leading to dissatisfied customers and potential order cancellations. If there is no product available in the inventory and your system is showing that the product is available, then it will naturally result into dissatisfaction of customers and potential order cancellations, because the company will not be able to supply the products to the customers as per their wishes. Next is privacy. It is also an important rule in the database. It means that only authorized users can access to the particular type of data which is there in the database. To secure data, that levels are set in the database and users can only view the data which is allowed to be seen. We have already learned the example of the same of branch manager, regional manager, that is they can view the data which has been, for which they have the permission to view the same. Now we will take another example of a hospital. Suppose there are 10 doctors. So suppose there is one doctor which is looking after 25 customers, 25 patients. There is another doctor which is looking after 10 other patients. So this first doctor will be in a position to see the medical records or the diagnosis or the treatment plans or the lab results of only these 25 patients, and the second doctor will be in a position to see the medical record and other lab reports of these 10 patients. This doctor cannot see its record or other, and this doctor cannot see these records, because the DBMS will ensure that they have access to the medical records of the patients which belong or which are being treated by him. In the same way, the nurses are also given access to the patient records, but their level of access is restricted as compared to the doctors. In the same way, there are lab technicians which are working in the hospital. They have access only to the laboratory related data. They cannot have access to the other type of record, such as accounts records, billing records, or what is their other medical position of the record. They will not have access to the medical records. They will have access only to the what is lab reports. Now there is also a billing department in the hospital. Now the billing department will not have access to the medical records or lab reports. It will have access only to the accounts purposes, accounts data. It will have access to the financial information relating to the patient, such as what is the bill outstanding, what is the insurance details, from where the insurance payment is to come, what amount has been deposited, what is the balance. So all this is the benefit of DBMS. That is, it ensures the privacy of the data and it can restrict the permission of the data. That is, only the authorized persons can have view to the particular type of data on the basis of the permission granted by the database administrators. We have already learned about the database administrators in our previous course. Next is concurrent access, which this is also one of the benefits of DBMS. What is the meaning of concurrent access? Concurrent access means multiple users or applications can access the database simultaneously. Multiple users can update, insert or delete data in the database concurrently without interfering in each other's data operations. But here DBMS ensures data concurrent access through mechanisms like locking, transaction isolation levels and transaction management. We will read about the same, that is the locking, isolation level, transaction management, in due course of time. We will understand the same with the help of an example. Suppose there are 10 employees working in an organization and they are making change in the data. Suppose there are 10 employees and 2 employees are attempting to make change in the data. Suppose there are 100 products available. This first employee wants to show that one product has been sold. This is the another employee and it wants to ensure that 2 products have been sold. So if both the employees are accessing the database concurrently, and if both these employees are allowed to commit the database, that is to make changes to the database, it will result in some confusion. Suppose this employee wants that 2 products have been sold and it wants the product to be sold as 98, and if they are making the change to the database at the same time, it will result in some confusion, because it is trying to attempt that the 2 products have been sold and the balance is 98. It is trying to attempt that it is 90. If this is allowed, first it will say that it is 98. If this is allowed, it will say that this is 99. So there is some confusion or some sort of mismatching may occur. So to ensure the consistency of data, there are mechanisms in the database such as locking, isolation level. We will read about the same, so that while many users are attempting to insert, delete or update the data, there is no data consistency is not data consistency is properly maintained, that is data is proper throughout the database system. Overall, the DBMS offers a comprehensive solution for managing data efficiently, improving data quality, ensuring data security and enabling effective decision making. Now the topic before us is how DBMS ensures concurrent access to data. Concurrent access means multiple users or applications can access the database simultaneously. DBMS ensures concurrent access to data. Concurrent access means multiple users or applications can assess and manipulate data simultaneously. Here the word has been used, assess and manipulate. What is the meaning of manipulation of data? Manipulation of data means inserting data, deleting data, updating data. Some of the key methods which are used by DBMS to achieve concurrent access include locking, transaction isolation levels, and transaction management. We will understand the same one by one. First is locking. Locking means to place a lock. When a particular user is reading or writing on a data in the database, the DBMS may place a lock on it so that some other user may not modify the data simultaneously. We will read it, what is written. Locking means that when a user or process assesses a resource means data element, record, object within the database for reading or writing, the DBMS can place a lock on that resource to prevent other users or processes from modifying it simultaneously until the operation is completed. Suppose you are reading something on the database, and if there are simultaneously, there may be other users, and if the other users update the data or make some certain changes in the data, then there will be problem, because you are reading the data and the data is changing frequently. So to solve that problem, DBMS places a lock when the reading or writing is going on. So there are two types of lock in the case of DBMS for concurrent access control. First is shared lock. It is also known as read lock. And the another is exclusive lock, that is write lock. Shared lock means the reading may be done by many persons. Exclusive lock or write lock means one particular user only may write or make changes to the database to the data at one time. Another user cannot delete the data at the same time. So now we will read in some more detail. First is shared lock or read lock. A read lock allows multiple users to access a resource for reading simultaneously, but it restricts write operations on the resource while all read locks are released. Next is exclusive lock or write lock. When the write lock is there, it prevents any other user or process from accessing the resource. Here the resource means the data element or particular type of record which you have accessed for reading as well as writing. That is, when the write lock is there, other user or process cannot access that resource for reading or writing. This exclusive access ensures that only the holder of the write lock can modify the resource while the lock is active. That is, only one user can make changes to the data at one particular time when the write lock is active. Only one person. Other user or processes may need to wait until the write lock is released before they can access the resource. That is, when the write lock is released, then the other users can access the same, preventing conflicts and maintaining data integrity. These locks help in maintaining data consistency and avoiding data anomalies when multiple users read or attempt to modify the same data concurrently. Concurrently means simultaneously at the same time. Now we will talk about isolation levels. In the DBMS, isolation levels define the degree to which a transaction is isolated from the modifications made by any other transaction in the database system. There are 4 types of isolation levels in the DBMS which are defined in the SQL standard, and these are read uncommitted. First question rises, what is the meaning of committed? Committed means the changes made in the database. If it is written as uncommitted, it means that the changes which have not been saved in the database. So there are 4 types of isolation levels: read uncommitted, read committed, repeatable read, and serializable. We will understand the same one by one. First is read uncommitted. This is the lowest level of isolation level, and this isolation level does not guarantee consistency in the data. Transactions can read data that has been modified by other transactions but not yet committed. Suppose there is a transaction T1 and there are other transactions T2, T3. Suppose there are 100 products and this transaction makes the change as reduces the number of products to 90. Though this change has not been changed, has not been committed, that is, this change has not been saved in the database, but the other transactions can see that the number of products are 90, though the same is not saved in the database. With this isolation level, any changes made by an employee A to the stock quantity of a product will be immediately visible to the other employee even before employee A's transaction is complete. That is, transaction of the employee A is not complete, but the other employee, say B, C, D, can see what changes have been made by the employee A. Now we will understand the same with the help of an example. Suppose there are 100 units of a particular product and the employee A initiates a transaction to update the stock quantity of the product X from 100 to 50. That is, the quantity is to be changed from 100 to 150. While the employee A's transaction is in progress, at the same time employee B checks the stock quantity. That is, A customer, A employee, and this is the B employee. Products are 100 and it is making change in the database, wants to change the number of products as 150. Though this change has not been saved in the database and the employee B sees how many products are there, he will see that there are 150 products, though the same has not been saved in the database. At this point, employee B may see that the interim change made by the employee A and observe that the stock quantity as 150 units. Suppose there is a power failure or any other problem in the net issue, that this type of change is not saved in the database. So it will result that employee B has seen that there are 150 products, but this change made by the employee A has not been made or saved in the database due to certain reasons. That is, the change has not been committed to the database. So while the employee B will have the impression that there are 150 products, actually, because the change has not been affected in the database, there are actually only 100 products. So there is inconsistency in the minds of the B in respect of the what is the availability of the product. However, if employees A's transaction fails or rolled back, the stock quantity will be reverted to the initial value of 100 units, leading to a discrepancy in the employee B's observation. While the employee B will think that the number of products are 150, the actual quantity will be only 100. Next is read committed isolation levels. Committed means the changes have been made in the database. If in this isolation level, transactions can only read committed changes made by the other transactions. With this isolation level, any changes made by the employee C to the inventory will only be visible to others after the transaction is fully committed. It means that Suppose this employee C starts a transaction. It wants to change the product quantity from 100 to 150. When the quantity of the products is changed to 150 and is saved in the database server, only then the employee D will see that the products are 150. In the meantime, when the transaction is undergoing and it is not saved at this isolation level, the employee D will not see the number of products as 150. He will see only that the products are 100. Now we will understand the same with the help of an example. Employee C starts a transaction to update the stock quantity of the product X from 100 to 200 units. When the transaction is in progress, employee D checks the quantity of the product. At this point, employee D will only see that the quantity of the product is only 100 units, and any changes made by the employee C will only be visible to others after the employee C's transaction is successfully completed. That is, when the employee C's transaction is fully committed, it is saved in the database, only then the other employees will be able to see the changes made by the employee C in the data. This type of isolation level prevents employee D or other employees from seeing intermediate or uncommitted changes, but may still lead to inconsistency if multiple reads are performed. Next level of isolation, next example of isolation level or next type of isolation level is repeatable read isolation levels. This level ensures that a transaction sees the same data throughout its duration, even if other transactions modify the data in the meantime. It means that suppose there is an employee E and there are other employees B, C, D. This employee sees that there are 100 products in the database, and the employee will continue to see this level, this quantity in the database. That is, what will be shown to him will be the 100 products. Now the other employees are concurrently changing the same. Suppose in the meantime this employee has changed the data to 120, this employee has then thereafter increased it to 130, this employee has changed it to say 120 again, because the products were increased, then it were again increased, then some products were sold and it was balance was 120. But the employee A will continue to see this product on its screen. How it happens? Due to repeatable read isolation levels. This type of isolation level is given to the audit persons, because when the audit is going on, it will have to keep in mind a particular entry, and only keeping in view that particular quantity it can make audit. It can view, the auditor can find out how many products were bought in the previous year, how many products were sold, and what is the balance. Only on the basis of this, the auditor can arrive at whether the actual quantity is available, whether the data is proper or not. If the data goes on changing continuously, then auditor cannot arrive at the final conclusion, or the audit will not be proper. Now we will read what is written. With this isolation level, when an employee starts the stock audit and reads the quantity of a specific product, the system ensures that the quantity employee initially read will remain constant and consistent throughout his entire stock audit transaction, even if other updates or changes are made to the product quantity by other employees concurrently. As already stated that though the changes may be made to the product quantity by the other employees, but what is being shown to the employee that is the auditor, it will remain the same. Here it is given example, it is the name of the employee is written as E. However, it is important to note that other employees, that is these employees B, C, D, may see different quantities if they perform their own reads or updates during this time. That is, what is being shown to E will not be, this may or may not be the same for others. They will see the actual update, what is there in the system at that time because of the updation done by the other employees. Now we will have this example in detail. Employee E begins a stock audit for product X and reads the stock quantity as 100 units. While employee E's audit is going on, employee F updates the stock quantity of the product to 120 units. That is, employee E, which is the auditor, has read the stock quantity as A. It has seen that the quantity is 100. At the same time, when the audit is going on, there is another employee named F. He updates the stock quantity as 120. Despite this update, the system ensures that the employee's initial read value of 100 unit remains consistent throughout his entire audit transaction. That is, employee will continue to see the product quantity as 100 and not 120. As a result, employee's audit remains accurate and avoids discrepancies in the process, even though new products may be added during the audit. Next isolation level, which is the highest isolation level, is serializable isolation level. This is the strict isolation level. This isolation level ensures that the concurrent transactions, that is simultaneous transactions, are executed as if they are executed serially one after the another. It means that suppose there are many employees or many users, say F, D, E, C, these are many users or employees which are concurrently doing many transactions at the same time to the database. So the DBMS system will ensure that suppose imply all these transactions are happening simultaneously. It will ensure that first this transaction is complete, only after that this, and only after that this. That is one after the another. It will ensure that the database system will ensure that all the transactions are happening in a serial position, a serial order. Let us read. This level guarantees the highest level of data consistency by preventing any interference or overlap between concurrent transactions. We read the same. Employee G starts a transaction to update the stock quantity of product to 180 units. That is, there are suppose 180 units of a particular product are available, and employee G is wanting, suppose there are 100 units and the employee G is going to update the products as 120, 180. While the transaction is being made by G, another employee, say H, is also attempting to update the stock quantity as 200, 250. However, the system enforces serializability and prevents employee H from proceeding until employee G's transaction is completed. That is, first the DBMS system will ensure that this level of isolation level will ensure that firstly the employee G's transaction will have to be completed, only after that employee H can execute his transaction or his transaction will be completed. This ensures full data consistency, but it may introduce some delay in highly concurrent situations. That is, employee H will not be able to perform or conclude his transaction until the employee G has concluded its transaction. The choice of the isolation level depends on the specific requirements of the application of system that utilizes the database and the need for data accuracy and concurrency in a multi-user environment. If there is higher isolation level, it means stronger data consistency, but this may reduce the number of concurrent transactions, because as already told in the previous example that if there is higher isolation level, more concurrent transactions cannot happen. There will be reduction in the number of concurrent transactions. However, if the isolation level is lower, it allows more transactions to happen concurrently. That is, at the same time, many transactions can happen. But lower isolation level may lead to data inconsistency, because different persons may different types of data at the same time, though the actual position may be different due to overlapping changes. Now the topic before us is benefits of using a database management system over traditional file-based systems. First point is structure. DBMS is a software for managing the database. On the other hand, file system is a way of organizing and storing data on a computer's storage medium such as hard disk drive or SSD, that is solid state drive. In the case of file system, data is stored in files and folders. Next is centralized data storage. DBMS enables centralized storage of data in a structured manner so that the data can be easily retrieved. On the other hand, the traditional file system often leads to data duplication and scattered data files, making data management and retrieval complex. That is, in the case of traditional file system, it is difficult to manage data and retrieve data. Next is data consistency and integrity. DBMS enforces data integrity through constraints and validation rules. Constraints may be unique constraints, primary key constraint, foreign key constraint, referential integrity constraint, or some default constraints. DBMS ensures data remains consistent and accurate throughout the database. That is, all the persons or all the users who have access to the data view the same data. On the other hand, traditional file-based system relies on manual checks and scattered data files, making data management and retrieval complex. Next point is concurrent data access. In the case of DBMS, multiple users can access and manipulate the data simultaneously without conflicts or data inconsistencies. Manipulation of data means updating the data, inserting data, or deleting data wherever necessary. In the case of traditional file system like those which is found on your computer, these systems, that is the file system, is not designed to handle situations where multiple users or processes can access the same file at the same time. Suppose you are having a computer, can 10 users can access the same data which is lying there on your computer? It is not possible in the case of traditional file system. Next is complexity and cost. In the case of DBMS, it is generally more complex and it is expensive to make use of DBMS because of the hardware or other software, because the DBMS is of advanced features. In the case of file system is simpler as compared to DBMS and it is more cost effective. That is, it is very less expensive as compared to DBMS. Next point is data sharing. DBMS supports data sharing among multiple users and applications. In the case of file system, data sharing may be challenging and prone to conflicts. Next is scalability. There may be chances that an organization is that the performance of the business of an organization is rising very fast. That is, the products are selling like hotcakes and more users are approaching its website. That is, the organization may have to handle a large volume of data for large number of users. If the DBMS is being used by the organization, then the DBMS can handle large volumes of data efficiently. DBMS can scale to accommodate terabytes or petabytes of data. That is, in the case of DBMS, more servers or more computers can be added, or we can upgrade a single server or a single computer, such as we can upgrade CPU, RAM or storage devices such as hard disk or SSD to handle the increased volume of data in case of DBMS. Whereas in case of file based system may face challenges in the case of scalability in managing large volume of data efficiently. As data grows, the performance may degrade. Next is backup. DBMS provides for regular automated backups at predetermined intervals, such as DBMS may backup at daily, hourly, or as has been specified for the DBMS system. DBMS ensures data integrity during the backup process even when the database is actively being used. It means that you are using database and at the same time backup is going on. There is no problem. Backup will be proper. But in the case of file system, there is problem. While system often lacks automated backups, users often need to perform manual backups. If a file is open or in use during the backup process, that is, file is open and at the same time backup is being performed in the case of file system, it may lead to incomplete or corrupted backups. That is, it may be possible that the file which is open will not be taken into consideration by the file system for backup purpose. Next point is point in time recovery. DBMS supports point in time recovery. It allows the user to restore a database to a specific moment or time in the past, that is to a state before a critical event or data loss occurred. It means that suppose there is accidental deletion of data. This is a human error, and some important or all critical data is lost due to this accidental mishandling or human error. It may be also possible that there is some system failure or software bug is there or some hardware failure is there, and due to which some data corruption has taken place. So DBMS comes into role here. It plays an important role and provides for point in time recovery. That is, it restores the database to a specific moment or a specific time in the past. Now the question arises, what is the point in time? Whether suppose the database has suffered or data loss has occurred now. Now what is the point in time? Whether the point in time will be 1 second earlier to this time, that is, suppose now it is 10. Now at 10 hours there is data loss. Whether the backup will be at 9.59, that is, the restoration of data will take place up to 9.59 or 1 hour before, 1 day before, or some more days before. So the point in time recovery depends upon the configuration as well as the capabilities of the DBMS, that is, up to which point the database has to be restored in the past. Next point, we take the case of file system. Traditional file-based system does not generally offer point-in-time recovery capabilities, making it difficult to restore the data to a specific moment in the past. File system lacks transaction logs and other mechanisms which are necessary for efficiently and effectively implementing point-in-time recovery. Next is data querying. DBMS provides a query language such as structured query language for querying and manipulating data. The file system, on the other hand, does not have a standardized querying language, and data retrieval typically involves searching for specific files and parsing the content of files manually, which can be time consuming and error prone. That is, if we have to search any file, we will have to manually search the same. Now the word has been used, parsing the content. Parsing the content of files manually refers to the process of extracting meaningful information or data from files without the assistance of automated tools or software. That is, in the case of DBMS, if we give the command to the DBMS, the DBMS will provide us the desired information in the desired format, that too very quickly. But in the case of file system, if we want to search any data, we will have to search the same manually, and we will have to extract the data as we desire. That is, we will have to form the format of our own. The system will not do it. We will have to search the data which we require from various locations, from various files. Next point is data analysis. DBMS is better for data analysis because it has powerful tools like structured query language, indexing, and aggregation functions. DBMS organizes data efficiently. On the other hand, file system lacks such tools which help in data analysis. So it is very cumbersome or difficult to extract data, combine and analyze data from the files manually, because a lot of time will be required for doing all these tasks. Next is data security. DBMS provides advanced data security features such as user authentication. User authentication may be done by the way of such as username, then password or two-way authentication. Access control, that is role-based access may be there or time-based access may be granted. Encryption and data integrity constraints. Data integrity constraints means unique constraints, primary key constraint, foreign key constraint, referential integrity constraint, or default constraints, which we have discussed earlier. DBMS ensures secure data storage and protects data against unauthorized access. File system do not have comprehensive built-in security features, so the file systems are more vulnerable to data breaches and unauthorized access, making them less suitable for handling sensitive and critical data securely. Next, we take the example of DBMS. Let us consider a website. The website pertains to the online bookstore, and that bookstore sells books, tracks the customers' orders, and manages inventory. The website uses a DBMS. The example may be MySQL, PostgreSQL, and the website uses DBMS to store and manage data efficiently. The information in respect of books such as titles, authors, price is stored in a structured table, whereas in the another table the customer data like name, address, orders and other contact details and order history is there. On the other hand, there is a separate table in which inventory data including the number of books available is stored. So with a DBMS, the website can easily retrieve specific book details such as who is its author, what is its price, track customer orders, that is how many orders have been placed by a particular customer in a particular period, and manage inventory details, that is how much books or how much quantity is available of a particular book. So all these type of queries can be made from the DBMS very quickly, and we can take appropriate steps. Suppose if the books are in short quantity as has been revealed by the DBMS, we can quickly, the online store can quickly order for the supply of the more. Complex queries can be executed using structured query language to provide various reports and insights such as the most popular books or best-selling authors. It means that DBMS helps us in a way that if we want to search that, or the online site wants to see which are those books which are in great demand, or which are the books which are not selling, all this type of information, or which customer is giving repeat orders, all this information can be provided to the user or the online store by the DBMS very quickly. Now we take the example of file system. Now let us consider a simple local bookstore with limited data management needs who uses a file system to store data. That local bookstore stores the information in individual text files on the computer, where each file contains details of one book, including its title, author, and price. Customer data is kept in separate text files with each one file per customer, and in each file the name of one customer, his name, order history is given. Now inventory information is stored in a single text file with basic list format, in which the quantity of available books is given. While this simple file system approach is very good for a small bookstore, it lacks the efficiency, data integrity, and advanced querying capabilities of a DBMS. We have already learned that in the case of DBMS, we can quickly find out what books are in great demand, which customer is giving repeat orders, which book is not selling at all. In the case of DBMS, we can quickly find out the same. But in the case of file system, we will have to go through various files to arrive at certain conclusions. So in the case of file system, it can be more challenging to manage and analyze data as the bookstore grows and needs more sophisticated data handling, such as it means that if the volume of the data increases, the file system may not be proper to handle the large volume of data, and the performance will decrease. In summary, DBMS provides efficient data management, whereas the file system is satisfactory for small scenarios, that is the small organizations, but file system is not suitable for storing and managing the large volume of data. Now the topic before us is disadvantages of database management system. While the database management system has many benefits, DBMS system has its own disadvantages. These are few of it the same. First is complexity, financial burden, single point of failure, performance, data security concerns, and so on. We will learn more about the same one by one. First is complexity. Using a database management system can be difficult and requires specialized skills and knowledge. Small organizations may not be having the resources as well as the expertise to manage the DBMS. So it is a barrier for those organizations who do not have the resources and expertise to manage the DBMS. Next point is financial burden. To acquire and to operate a robust database management system can be expensive because the organization may have to pay license fees, the organization may have to buy necessary hardware, and when the organization is utilizing DBMS, it may also have to incur expenses towards its maintenance. And in the case of big organizations, or if the organization wants to make use of latest technology DBMS, the costs may be quite enormous. Next is single point of failure. A DBMS represents a single point of failure for the entire system. It means that if the DBMS goes offline, or if the DBMS experiences a critical failure, the entire system may stop working. all the applications relying on DBMS may stop working too. Here we take the example of an online retail store. If the DBMS goes down or stops working, the website of the online store will not show any product to any customer. The customers will not be able to log into their accounts. No inventory will be shown on the site. That is all, the system will come to standstill. So this single point of failure of DBMS can cause service disruptions and negatively affect the business. Next is performance. Sometimes DBMS can slow down the overall performance of the system, especially in the case of large databases or complex queries. Next point is data security concerns. If the database management system is not properly configured and managed, unauthorized access to the data may occur. This can lead to loss or theft of valuable or critical or secret information to unauthorized persons. Next point is data redundancy. In some cases, database management system can create data duplication due to various factors such as improper database design and lack of normalization. Data duplication means the same data is stored at multiple places. If the data duplication occurs, it can increase the storage requirements. Further, changes made to one instance of data might not be reflected in all duplicate copies, leading to data inconsistencies. Next point is scalability challenges. Scaling a DBMS means to expand the capabilities of the system to handle more data and concurrent access. It means that if the business of an organization is increasing very rapidly, it is, and the organization is selling more and more products to more and more customers, then it is may be required on the part of the organization to upgrade their servers or to increase the number of servers or the computers so that it can handle the increase in to handle the large volume of data or increase in the number of users. Scaling a DBMS can be difficult, although modern DBMS technologies have made enormous progress in this area. Scaling still requires careful planning, and of course a huge investments may be required if we want to scale up, that is if we want to increase the number of servers or the number of computers. Here is an example. An e-commerce website facing rapid growth in user traffic and product data might need to scale its DBMS, which requires careful planning and investment. It means that an e-commerce website that the products of an products on an e-commerce website are selling in increasing numbers, that is its customers are increasing day by day, so that website will have to handle large volume of data, large number of customers. So the organization will have to increase the capabilities of the DBMS, that is it will have to make arrangement for more servers, more computers to handle the increase in large volume of data or and also to handle the more number of customers, and all this requires careful planning and also huge investment. Next is vendor lock-in. Vendor lock-in in the context of DBMS refers to a situation where an organization becomes heavily dependent on specific vendors DBMS technology. It means that suppose you are using a DBMS technology which has been supplied by say IBM or Oracle or Microsoft. You become accustomed to using that DBMS because each DBMS has its own characteristics and your organization is using that DBMS. That is the DBMS being sold by a particular vendor which may be Oracle, Microsoft or others. Then if you want, or if the organization which is utilizing the DBMS technology of a particular vendor, and if it wants to switch over to another vendor from say Oracle to Microsoft or Microsoft to some other Postgre or other, it is very difficult. It may be difficult or impractical in future because each DBMS has its own benefits, and transitioning from one DBMS technology to other DBMS technology may require lot of skills, lot of efforts and resources, and of course new investment. This can restrict a company's flexibility and prevent them from taking advantage of potentially better alternatives. That is, it may be possible that the DBMS technology of another vendor is good, but in view of the expertise, resources, or the other problems or efforts which may be required, and you as an individual or an organization cannot afford the same, then you as an individual or organization cannot take the benefit of the new technology which is being offered by the another vendor of DBMS. Next is learning curve. With the passage of time, new and new advancements are taking place in the DBMS field. So if you want to learn what is happening in the field of DBMS, what is the latest technology which is taking place in the DBMS field, so to have the knowledge about the same, you will have to devote a lot of time, efforts and resources. But every organization cannot afford to have to so much resources or efforts to take into account or to go through all the changes which are taking place in the DBMS field. It is very difficult to stay updated with the latest features and best practices in DBMS technology. So this learning curve can slow down and hinder the adoption of new features or technologies by an organization, because every organization cannot afford to spend a large amount of money to adopt latest technology or to have the knowledge about the latest technology. All the organizations cannot afford to do the same. Only the big organizations or the organizations which have the interest in this regard can afford to do the same. Next point is lack of flexibility. DBMS can lack flexibility because a lot of efforts may be required. So DBMS makes it difficult to change the database structure or add new features. Next is backup and recovery. Managing backups and recovery processes in DBMS can be complex and time consuming, especially in the large scale and distributed database. Distributed database means the database is spread at various servers. Though DBMS has some drawbacks, but it also gives us a lot of benefits. DBMS is able to efficiently handle the data. It can store the data effectively, and if we want retrieval of data, then the DBMS is able to handle the same very efficiently. Organizations need to consider both the benefits and limitations DBMS and make informed decisions on the basis of their specific needs and resources. Now the next point is, when not to use a database management system. We should not use a database management system if we do not have the budget or the expertise to operate a DBMS. If we have the money, but if we do not know how to operate the same, or we do not have the skilled labor, we should not use the DBMS. In such cases, Excel or flat files may be used to manage the or store the data. Now we will conclude this course. A database management system offers many benefits such as data integration, data independence, data consistency, data security, data backup and recovery, which contribute to efficient and effective data management. DBMS automatically takes care of data backup and recovery. DBMS provides data security by incorporating security measures such as user authentication, role-based access, and time-based access. DBMS provides the benefits of data consistency, integration, integrity. DBMS ensures concurrent access to data by using techniques such as locking, read lock, write lock, transaction isolation levels, and transaction management. There are 4 types of isolation levels. Even though DBMS has some drawbacks, DBMS also provides us a lot of benefits. DBMS is able to efficiently store, handle, retrieve the data so that the organizations can make decisions on the basis of the same. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.